Since its incorporation, Ewimar has been designing and manufacturing electronic devices for security systems, network infrastructure, and automation. The main product line consists of surge protection systems, supplemented with solutions that simplify installations and reduce the number of accessories used therein. In addition, our offer includes products designed to integrate systems of various manufacturers, devices for wireless transmission, telemetry, power supply, and control. Surge protection systems are characterized by many important parameters. They determine the effectiveness of their operation and the impact of the applied solutions on the transmitted signals. When selecting surge arresters for an installation, make sure that all the important parameters have been specified by the manufacturer along with their values. Classification of surge arresters and testing methods are defined by the harmonized standard PN EN 61643 Part 21 from the year 2004. It allows to compare the actual features of products offered by different manufacturers that have been tested according to the assumptions contained therein. The standard specifies many important parameters, but the most key ones include surge current rating, voltage protection level, and circuit attenuation. During laboratory testing, a pulse shape with a specific rise and fall time is formed. For arresters for low-current installations, surge current values are typically specified for the 8/20 microsecond pulse shape. However, it happens that the parameters may be given for a different pulse shape, so that they will vary by multiple values. When comparing the performance of arresters, it is very important to do so for the same shock pulse shape. The line-to-ground surge resistance determines the maximum current that can be dissipated by the arrestor from the protected conductor to the ground. Due to the effective discharge of the surge, the voltage potential with respect to earth is reduced. This prevents current from flowing through the protected device and high voltage jumps to the devices and wires of other installations. The line-to-line surge resistance is the ability to suppress the surge current occurring between individual conductors in a wire. It occurs as a result of an induced surge pulse within a few hundred meters of the lightning strike. Despite its low value, it is the most frequent cause of damage to digital and analog interfaces, as well as internal power supplies using impulse technology. The voltage protection level is the ability to effectively reduce the high voltage that accompanies lightning. By reducing voltage between the protected device and the ground, as well as between individual conductors of wires, we prevent an increased flow of electric current through electronic components, which prevents them from overheating. The ability to reduce high voltage depends largely on the design of the surge arrestor, the quality of the components, and the technology used. Proper selection of arresters for low-current installations is not easy, because they're never completely neutral. Some systems, especially those using high-frequency transmission, require arresters specifically designed for them. It is particularly difficult to protect digital signals where fast voltage switching generates large amounts of noise. They can easily spread to other wires or equipment, limiting proper transmission or even blocking it completely. Many manufacturers of surge arresters ignore proper execution of printed circuit boards and the quality of components used. Accumulation of a large number of arresters of questionable quality in one place can cause large disturbances and interference. The arresters dedicated for LAN transmission systems manufactured by Ewimar have precisely calculated and designed printed circuits, complemented by rigorously controlled manufacturing process. An example of the highest quality manufacturing are products dedicated for Gigabit Ethernet networks. When tested with certified meters, they clearly differed in performance from competing products, particularly in attenuation and inter-channel crosstalk. Is surge protection built directly into electronic devices effective enough? The undoubted advantage of such solutions is a better integrity of digital signals, since components placed directly in the device have a negligible influence on such device. The built-in surge protection also does not add much to the price of the product itself. However, the resistance to surge current is not only about the protective components used. The durability of the printed circuit boards is also crucial. Modern ICs have very small dimensions and leads placed very close to each other, which forces the use of laminate with very thin copper coating. The use of protective components capable of eliminating kiloampere surge current makes little sense because the printed circuit will easily burn out when they're triggered. Producing printed circuits for high-integration scale components is not possible with a laminate with a thick copper layer, as this completely rules out the etching process. In summary, surge protection products must be separately designed electronic devices, because only such can meet the appropriate technical requirements. For effective surge protection, in addition to proper selection of surge arresters, there are several practical rules to remember. The most beneficial protection is provided by using surge arresters at the two ends of each cable or at each device in the case of a digital bus. EN 61643 standard does not specify parameters of grounding resistance, but it should be of the best quality and have the shortest possible path. A discharge line that is too long can cause a charge to be discharged to the ground too late, causing the protective device to fail. Do not connect the grounding of arresters to the lightning protection system, and keep the grounding point at least several meters away from the system. This will prevent the surge from backing up from the lightning protection system to the surge arrestor through the ground. Surge arresters are usually neutral to the direction of operating current flow, but their operation for surge protection is mostly directional. The side of the arrestor marked protected should always be connected in the direction of the device to be protected, and the side marked endangered should always be connected in the direction from where the danger may arise. Reversing the connection may result in improper operation of the arrestor during the lightning strike or even cause damage to the arrestor. Sales partners, system designers, and installers are offered extensive technical and marketing support, training, and materials to facilitate projects. Thank you for looking at our material.